Bismillahirrahmanirrahim. Welcome dear students of first year MBBS, BDS and DPT. Today's lecture is about the time and voltage calculation and origin of ECG waves. At the end of this lecture, you will be able to explain voltage and time calculation from ECG, origin and characteristic features of P wave, QRS complex, T wave and U wave. You will also be able to explain what happens with the appearance of atrial repolarization wave that is called atrial T wave. Why does T wave appears as positive wave being repolarization wave? What are different abnormal patterns of these waves? The first we will discuss about the voltage calibration of the ECG. From this strip, you can easily see that the ECG strip is composed of large boxes, and within the large boxes, the small boxes are present. Each large box is composed of vertical lines, and in the same manner, the large box is composed of horizontal lines. The blue ones are vertical lines, while the red one are horizontal lines. The horizontal lines are used for voltage calibration, while the vertical lines are used for time calculation. The horizontal lines on this ECG, they are arranged such that 10 of the horizontal lines, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 of the small horizontal lines upward or downward represents 1 millivolt with positivity in the upward direction, while negativity in downward direction. By using these features of voltage calibration, we will calculate the voltage of P wave, QRS complex, T wave in the next coming slides. Next is time calibration of the ECG. A typical ECG paper is run at a paper speed of 25 millimeter per second, and the vertical lines on ECG, as we mentioned in the previous slide, the vertical lines on the ECG are time calibration lines. Therefore, each 25 mm in the horizontal direction, each 25 millimeter in the horizontal direction is equal to 1 second. Each of this each 5 millimeter segment, each 5 millimeter segment indicated in this bold red color between these two dark vertical lines, it represents zero point 0.2 seconds. So the 0.2 second, this 0.2 second interval are then broken into 5 small boxes by thin vertical lines. Each of small box will represent 0.04 seconds. So each large box in horizontal direction is equal to 0.20 seconds, and each small box represents 0.04 seconds. So the first wave is P wave, and P wave, as we mentioned previously, is caused by electrical potentials generated when the atria depolarize before atrial contraction begins. So simply, the P wave is due to depolarization of both atria. The voltage of P wave is between zero point 0.1 to 0.3 millivolts. As we mentioned, the voltage is calculated by horizontal lines. So if we see from this normal diagram, so this is the vertical line, then and this is the third vertical line. So this represents zero point 0.1 millivolts and this represents 0.1 millivolts. So it is almost the voltage from this normal strip. The voltage of ECG is almost point less than 0.2 millivolts. Its duration is 0.12 seconds. As we mentioned, the P wave starts from here. So this is the first small box. This is half. This is 1. This is 2. And this is third small box. As we mentioned, each small box is equal to 0.4 multiplied by 3 is equal to 0.12 seconds. As it is half, so we can say it is between 0.14 seconds. These are the normal features of the P wave. Some of the abnormal P wave patterns appears in ECG. This is the first pattern in which there are no P waves. There are no P waves and P waves are replaced by series of fine regular oscillations called F waves, and this occurs in case of atrial fibrillation. So these are the fine oscillations instead of P wave, and these are called F waves. Now this is pattern number 2, in which we can see that there is double P wave, and this double P wave is called bifid P wave, and this bifid P wave, this appears in certain kind of arrhythmias or in valvular heart defects. Then this is the third pattern in which the P wave, this is the normal P wave. This is the normal voltage of P wave, that is about 0.15 millivolts. But when there is mitral stenosis, mitral stenosis means narrowing of the mitral valve. In that condition, the P wave, it becomes prominent as compared to this normal P wave. It becomes prominent and its voltage becomes more than normal. Then this is the third pattern in which the P wave gives sawtooth appearance, and it occurs in atrial flutter, a kind of arrhythmia that we will discuss in the fourth or fifth lecture on the ECG. Then this is the ECG pattern in which this is normal P wave, this one is normal P wave, but here you can see that there is no P wave. And this occurs in tachycardias due to some abnormality in conduction system. The so-called atrial repolarization wave, that is called atrial T wave. It follows 0.15 seconds after atrial P wave, and as we can see that it appears as negative deflection. In the normal ECG, the atrial T wave does not appear. The reason is that the atrial T wave appears 0.15 seconds after P wave, and this is the same time when QRS complex of ventricles appear on ECG. Therefore, it is obscured by large ventricular QRS complex. The next is the QRS complex, and the QRS complex, it appears due to ventricular depolarization, and it represents excitation of both ventricles. The voltage of QRS complex is 1 to 1.5 millivolts from top of R wave to bottom of S wave. Its normal duration is 0.08 seconds, means it is composed of two small boxes. In QRS complex, the R wave is positive. Q wave is the first deflection. In QRS complex, and it appears as negative. The R wave, the and this Q wave, it appears due to depolarization of ventricular septum from left to right, while R wave, it appears due to depolarization of lower part of ventricular segment and apex of the heart. S wave, it appears due to depolarization of ventricular walls and base of ventricles. Usually, there are two abnormalities of the QRS complex. The first one is in which the QRS complex it widens. QRS complex widens and it appears in case of bundle branch block. And the second one is in which the QRS complex becomes wide and deformed, and it appears in case of ventricular extrasystoly. The T wave represents ventricular repolarization, and ventricles repolarize about 0.25 to 0.35 seconds after depolarization. The voltage of T wave is about 0.2 to 0.3 millivolts, and duration of T wave is between, if we calculate from this diagram also, it is between 0.25 to 0.27 seconds. It is composed of, as we calculate from this diagram, it is the normal duration is about 3 small squares. The duration is, and the normal duration that is calculated about T wave is between 0.25 to 0.2 seconds. Its normal range. Then regarding abnormalities, this is the normal T wave, and the T wave it becomes tall and tented in case of hyperkalemia. The normal potassium level is between 4 to 5.5 milliequivalent per liter. But when this level increases, it becomes more than 5. The amplitude and voltage of the T wave it starts increasing, and when plasma potassium level rises to about 7 milliequivalent, the T wave becomes tall and tented. and still there is P wave, means atrial activity is present. But if the plasma potassium level reaches up to 8.5 milliequivalent, then the QRS complex, it widens, T wave becomes tall and tented, no P wave. If this level further increases, it may leads to ventricular tachycardia or ventricular fibrillation. The two types of arrhythmias that we will discuss in detail on lecture on arrhythmias. Then T wave becomes inverted in case of ischemic heart disease. Why does why does T wave appears above the isoelectric line being repolarization wave? The reason for this is repolarization of ventricles begins about 0.15 second after the depolarization of the ventricles. Repolarization of ventricles completes in about 0.35 seconds, and this repolarization produces T wave. Normally, if we see the direction of cardiac impulse from SA node to the ventricles is from above to downward, and this direction is called the mean vector of ECG, and it is about 59 degrees. So anything that deviates from this vector, like in this direction or in this direction, in the opposite directions, it appears as negative wave. The septum means interventricular septum and endocardial areas of the ventricles depolarize first. Then according to principle, and principle is that the area that depolarizes first will repolarize first. But this is not the case in case of ventricles. And this is the reason that T wave appears above line, isoelectric line. The explanation of this is the septum and endocardial areas have longer period of contraction, longer period of contraction than most of the external surfaces of heart. Therefore, the entire outer surface of the ventricles, outer surface of ventricles repolarizes first, while septum plus endocardial areas repolarizes late, because as we mentioned, because of in contraction state. This sequence of repolarization is postulated to be caused by, it is caused by high blood pressure inside the ventricles, caused by high blood pressure inside the ventricles during contraction, and this greatly reduces blood flow to endocardium, thereby slowing a repolarization in endocardial areas. The reason of this positivity, reason of T wave positivity, as the outer surface of the ventricles repolarizes first, outer surface repolarizes first before the inner surfaces. The positive end of overall vector is towards the apex of the heart. Therefore, normal T wave appears as positive wave, which is the polarity of most of the QRS complex. As mentioned in the first lecture on ECG, that there is slight positive deflection after T wave, and that is called U wave. The U wave is probably due to slow repolarization of interventricular conduction system and papillary muscles. And the U wave is normally seen in thin, lean persons. Abnormally, U wave appears in case of hypokalemia. Now, as you people asked in the previous lecture that why U wave appears after the T wave, so the most probable answer to your question is that due to slow blood flow in the septum and interventricular conduction system, slow repolarization occurs, and this slow repolarization leads to appearance of U wave after T wave. In the next lecture, we will study the segments and intervals of the ECG and their clinical importance. Thank you very much for being with us. Allah Hafiz.